All right, lessons on limits at infinity. And really this is a lesson on end behavior of a function. So, given a power function, do you understand the end behavior? If it's an even function, both ends go up or both ends go down. So in this case, the left end and the right end are up. In this case, if it's odd, one end goes up, one end goes down. If it's positive, the right end goes up and the left end goes down. So let P be that polynomial. Then, if you're thinking of a left end behavior, the limit as x approaches negative infinity of the power function. So in other words, you only have to look at the power function to understand where the end is going. And same thing here, you only have to look at the power function to understand what's happening. So there's a mathy way of describing, hey, look at the power function, understand where the power function is going for the right end and the left end behavior. So let's look. So what's the limit as x approaches negative infinity? That means the same as where's the left end going? So look at the power function here. So that's the same as asking what's the limit as x approaches negative infinity of just x to the fourth? So what term has the greatest exponent? Just look at that and what's happening. So this power function is even and positive. Both ends go up. So the answer here is infinity. If I look here at this polynomial, identify the power function first. So it's the limit as x approaches infinity. And just the power function is, and the negative is essential, negative x cubed. So when I think of negative x cubed, we have odd and negative. So that means the right end goes down and the left end goes up. So the right end behavior here goes to negative infinity. Number 3, identify the power term. That's 6x squared. Understand the power term is even with a positive coefficient, so both ends go up. So if both go up, then definitely the right end is up. Again, identify the power. So as x approaches negative infinity, negative 2x to the fifth. So identify the power term. That's the term with the greatest exponent. Understand it's negative with an odd exponent. So that means the right end goes down and the left end goes up. So the left end then goes to infinity. Number 5, identify the power term. So the limit as x approaches negative infinity. The power term is negative 8 x to the 6th. It's the term with the biggest exponent. That includes the sign in front of it. An even exponent and negative means both ends go down. And there's your answer. The limit as x approaches infinity is the right end behavior. The power term is right here, the one with the biggest exponent. Recognize it's negative and odd, so the right end goes down and the left end goes up. So the answer here is negative infinity. All right, turn the page. Now, what we were looking at is the end behavior of a polynomial. Now, what happens if it's a rational function? What are we going to do? So the end behavior of a rational goes to a number, the horizontal asymptote. So when I look at 1 over x, as you put in larger numbers for x, this fraction gets closer and closer to 0. And on both sides, that's this end and this end. So both ends get closer and closer to 0. Same here. So if I look at what's the end behavior here, I'm not looking in the middle, I'm looking at the ends. So if you put in larger and larger and larger numbers for x, this fraction gets closer and closer to 0, both positive and negative numbers. Both ends are getting closer to 0. The middle is as x approaches 0, that'd be different. So evaluate each limit and understand that when you see a fraction, as you put in infinity or negative infinity, understand that that approaches 0. So if I look here, what's the limit as x approaches infinity? Look at this fraction. The larger the number you put into the fraction, this is going to be 0. And then we still have a negative 7. So altogether, it's approaching -7. If I look at 8, both are fractions, both have variables. So as you put in numbers that are positive or negative into the denominator, both fractions are getting closer and closer to 0. So it's really 0 plus 0. The answer is 0. So given a rational function, we're looking at the power terms that will determine the end behavior. So if I want to understand this, what's the power term on top? 6x squared. What's the power term on the bottom? 2x cubed. And really what we're looking for is the horizontal asymptote, but we're looking for the end behavior. So if the denominator is more powerful, and all we're looking for are the exponents on the variable. 6 divided by 2 has no power compared to the exponents. So notice the numerator is less powerful, or the denominator is more powerful. Whenever the denominator is more powerful, that tells you what direction it's going. So in this case, it's going to 0. The limit as x approaches infinity. And again, just looking at the power terms, which is 2x over x to the 4th. Notice the bottom is more powerful. Whenever the bottom is more powerful, both ends are approaching 0. And that's as simple as it is. What happens when the numerator is more powerful? Then we have a little bit more work to do. So the limit as x approaches infinity, we have 5x to the 4th, and then the power term in the bottom is x squared. Simplify this, and you get the limit as x approaches infinity of 5x squared. So when you divide, subtract the exponents. Now this is like what we did at the beginning of the lesson. This is like a polynomial. What's the end behavior here? Even with a positive in front. So an even exponent, it's positive. Both ends go up. So the answer here is infinity. Look at number 12. Don't forget about the negative sign. So I just want to look, first of all, the numerator is more powerful than the denominator. So it takes a little bit more work to understand the end behavior. So I have x cubed and 2x squared. I'm only looking at the power terms and recognizing there's a negative in front. Simplify it, and really, you don't see it, but it's 1/2. So it's -1/2. Subtract the exponents, and it's -1/2 x. So we have an odd exponent, and it's negative. And really, if you think of it, it's a line, right? And it's going down to the right. It has a negative slope. So the question is, what's the right end behavior? And you can see, where's the right end going if it's negative and an odd exponent? And the answer is -infinity. What happens if the power terms are the same? Again, this is like finding the horizontal asymptote. So if they have the same power, so the greatest exponent in the numerator and denominator, they match, take the whole term and divide them, and there's your answer. So the x's divide out. 2 divided by 8 is 1/4, and that's it. We have no variables. That is the number. And honestly, if you were asked for what the horizontal asymptote is, that's what it is. And here's our last one for the lesson. Notice that they have the same exponent. They have the same power. So I'm going to write the limit notation. So I have 10x cubed and -2x cubed. So don't forget that negative. Recognize the x cubes divide out, and the answer is just -5. And that would be the same as if I asked you for the horizontal asymptote. So looking at the examples above, and if you have a rational function, if the top is less powerful than the bottom, then the limit goes to what answer? If the top is more powerful than the bottom, then the answer is going to be either positive or -infinity. And if they equal each other, then you have to divide p divided by q, the power terms, and that will give you an answer to whatever the constant is. All right, Mr. G Math over and out. Until next time.